Richard James will present the first tutorial in simplifying expressions. There's nothing to simplifying an expression apart from making it simpler. However, this might require that we apply quite a few mathematical principles from quite a few branches of the subject. We need to be able to manipulate fractions. We also need to be able to manipulate positive and negative numbers. We also need to be able to manipulate algebraic expressions. We may also be required to demonstrate a knowledge of factorization. This is mathematics, and as long as we remain within the confines of the subject, we are to be prepared for anything. We should never be surprised by something that we consider to be unrelated to the topic. As long as it is mathematics, we should be ready for it at all times. Simplifying expressions. For this and a few of the early problems, all that we need to do is expand the brackets and combine the like terms, if any, in the end. There we have the expression. What do we do? When multiplying, we need to be mindful of the signs. So keep the manipulation principles of signs in our minds. When multiplying two numbers, if the signs are different, then the answer is negative. And if the signs are the same, the answer is positive. And of course, that pertains to the multiplication of two numbers or two terms. There we have 2 times 5x, 10x, and 2, not 2 times y, but 2 times a negative y, negative 2y. And here we have not 3 3's, but negative 3 times 3x, and that will give us a negative 9x. And your favorite, negative times negative is equal to positive. So we cannot multiply without considering the signs. Finish by adding the like terms. Do not forget that when we add numbers that have different signs, we subtract the smaller from the larger, and the answer will take the same sign as the larger. Like terms. 10x minus 9x. When we are adding algebraic expressions, we can only combine like terms, and we combine like terms by adding their coefficients. So we are combining this 10 with this negative 9. That will give us 1. 1 will be the coefficient of x, but we know that 1x is equal to x. There we have it. And also, what do we have there? We have negative 2y plus 3y. When we add these numbers with different signs, we subtract the smaller from the larger. 2 from 3 is 1. And the answer will take the same sign as the larger. 3 is larger than 2. The answer will take the same sign as the sign of the 3. The the sign of the 3 is positive in this case, so a positive 1y. So a positive 1y, and we know that 1y is the same as y. When expanding brackets, we need to use the term that precedes the brackets to multiply each of the terms that is inside of the brackets. And let us take a look at what that means. One year, CXE CSEC report said that when students are attempting to expand brackets, they say 2 times 3x, 6x, and they plus 1, not mindful or not exercising the presence of mind that they need to multiply this one by the 2 also. So I am saying here that we need to remember that we need to multiply the 2 by the 3x and also the 2 by the 1. When multiplying, we need to be mindful of the signs. Like signs will give a positive answer, and unlike signs will give a negative. The negative sign that precedes the brackets that we have right here may be treated like a negative 1. So let us go. 2 times 3x, 6x. Then we have to take the 2 to multiply this one. So we have 2 ones, 2. And here we will treat this like a negative 1. Negative times positive is equal to negative. So we have a negative x and we have a negative 2 right there. Do not forget that what we are multiplying here needs to be taken inside of the brackets to multiply the first and also to multiply the second. Finish by adding the like terms. We will add the like terms. We have what? These two. 6x minus x is equal to 5x. And what do we know? Positive 2 and a negative 2 are additive inverses. When we add them, the result will be 0. So, adding those additive inverses, the result is 0. And adding 0 to an expression or number does not change its value. Therefore, it is unnecessary to have this plus 0 right here. But if you have it, it is not incorrect. So we may eliminate that 0. When expanding brackets, we are applying the distributive law that says multiplication is distributive over addition and subtraction. So we are applying the distributive law. The term that precedes the brackets should be distributed because we are applying the distributive law. So the term that precedes the bracket should be distributed to each of the terms inside of the brackets for distribution and for the distributive law. With nothing to multiply 2y, it returns as it is, following which 3 is distributed to each of the terms inside of the brackets. 2 will return, and that 3 multiplies y, and that 3 multiplies 1. No, it multiplies negative 1. Always be mindful of the sign, and that will give us a negative 3. And what do we do next? The like terms are combined, and the unique term will return as it is. So those will be combined by adding their coefficients, coefficient of 2, coefficient of 3. Add them, we get 5, and we will attach that term y to it, and this one, being unique, will return as it is. When expanding brackets, we are applying the distributive law. The term that precedes the brackets should be distributed to each of the terms inside of the brackets. We may have this mentioned 100 times, because a common mistake that students make is that when they have the expression, they multiply the first one, but they do not multiply the second one. With nothing to multiply 3m, it returns as it is, following which negative 2 is distributed to each of the terms inside of the brackets. So that will return. And this negative 2 times m, negative 2m. And negative multiplied by positive is equal to negative. The like terms are combined, and the unique term will return as it is. Adding the coefficient, 3 minus 2 is 1. 1m is the same as m, and the unique term returns. One mistake that students make also is that they combine the like terms and they do not remember, or they do not consider to include that unique term, or if we have quite a few unique terms. One common mistake that candidates make when expanding brackets is that they multiply the first term inside of the brackets, but they do not do the same for the second one. We will not make that mistake here. When multiplying, we need to be mindful of the signs. When we multiply two numbers with like signs, the answer is positive. And when we multiply two numbers with unlike signs, the answer is negative. And we will treat this negative sign that precedes this bracket as a negative 1. Do not forget this negative. Negative 9. What do we have there? A negative 3. And here, negative with this. Right. But we cannot turn a blind eye on the fact that we are multiplying negative by negative, so we will have a positive 3 right there. And we see additive inverses. Additive inverses cancel each other, and when adding numbers that have the same sign, we add the values and the answer will take the same sign as the numbers that we have added. So we have right here, we have additive inverses, but we will not add those first. We will add the like terms in x first, and they have like signs, therefore we will add the value 6 plus 9, 15, and the answer will take the same sign as those numbers. And what do we know? Additive inverses will eliminate each other, and negative 3 plus 3 no doubt is equal to 0, but that 0 is not necessary and will go away. Nice. The contents of the first brackets will be multiplied by the contents of the second brackets. We will begin by using the first term in the first brackets to multiply each of the terms in the second one. So there we have an expression somewhat different from the ones that we have simplified so far. This one requires that we multiply this by all of this. What do? We take this to multiply this and this. Then we take this to multiply this and this, and we will demonstrate. 2 3 is 6, but do not forget x multiplied by x squared is equal to x multiplied by x is equal to x squared. Then we have 2x with a negative 4. Positive times negative, negative 8x. Then we do now the 5. 5 3s 15, 15x, and 5 times negative 4, negative 20. And we only have a pair of like terms right there. So for the like terms, remember that when we add numbers that have different signs, we subtract the smaller from the larger, and the answer will take the same sign as the larger. And that is what we have for those like terms. They have different signs, so we subtract the smaller from the larger, and the answer will take the same sign as the larger. When we are having this addition-subtraction relationship with numbers that have different signs, we may use a rule of thumb. When they are different, we find the difference. Otherwise, we will have to add them. So when they are different, the signs are different, we find the difference. But if the signs are the same, whether they be negatives or positives, then we will add. As long as the signs are not different, then we will add. So we have a positive 7x right there. And what do we know? The unique terms are included as they are. In this particular case, we have 2 unique terms, and we will throw them in without any changes. So far, we have taken a look at expressions that are simplified by combining like terms. In the remaining problems, no doubt, we will have to meet the same requirement. Additionally, we will have to manipulate fractions, and immediately to follow, we have to apply the skill of factorization. So immediately, that means the one that we will be solving next, we will require factorization. We will see that for the most part, we will have to add algebraic terms, like we have done before. We will not kill ourselves over the process that are analogous to those that we have executed so far. We will assume a knowledge of their solutions and pay attention to some other necessary details. Given an expression like the one that we have there, some candidates would imagine that they immediately know what to do in order to simplify it. They may think that it is a no-brainer because the steps that they would use to simplify it are so obvious. But for me, they are not so obvious. For example, this is how some candidate may take a go at it. They would go straight ahead and cancel the 9's because 9 is in the numerator and 9 is in the denominator. Why not? Let's go straight ahead and do it. X into x squared is x, and y into y squared is y. For the one that is squared, just crossing off the power of 2 will give the correct result. So they will go straight ahead and also cancel. X into x squared is x, so they just cancel the square here. And they also do the same there. And the result is as desired. But I do not know what their final answer would be, because whatever it is, it cannot be right. So I am doing this because I see this happening time and time and again, and I am saying that it is not correct. No doubt, I have done that, and I am doing it to demonstrate or to catch the eye of someone who is watching this video, who is always taking steps like that. And I am saying that you cannot do that and be correct. But there's a correct way to approach that problem. We already know from primary school that we cannot reduce a fraction unless we can identify a factor that is present in both numerator and denominator. So in order to reduce the fraction, we have to have a factor that is in the numerator, and that factor is also in the denominator. The same is true for an algebraic expression. We cannot reduce it unless we have a factor that is common to both numerator and denominator. So we have to have factors that are common before we can cancel, because we can only cancel common factors. Surely we may be able to tell by looking, but in order to demonstrate that we can reduce the fraction and that we have taken the correct steps in doing so, we need to factorize both numerator and denominator if possible. Now what I'm saying is that you see this 9 here and the other one right here, you immediately cancel the 9s because you see 9. But this 9 here is not a factor of the entire numerator, and this 9 that we have here is not a factor of the entire denominator. The fact that we have 9 present in the numerator and 9 present in the denominator does not make the 9s factors of either numerator or denominator. And because they are not actual factors of the numerator and the denominator, then you cannot reduce by a common factor of 9. So let us attempt to factorize both numerator and denominator if possible. After factorizing, if and only if there are common factors, we may reduce the fraction. If there is no common factor, we may reduce, and it is even worse if one or both of the expressions cannot be factorized. So we have to factorize first, and if we have common factors, then we may reduce. If we do not have common factors, then we may not reduce. And it is even worse if we do not have factors of one of the expressions. So it is worst if one of the expressions cannot be factorized. That means we cannot proceed to reduce the fractions. The numerator is in the form of a difference of 2 squares and may be factorized as follows. Now we have the difference of 2 squares right there, and we are simplifying expressions. When we are simplifying expressions, do not imagine that it is far-fetched that our knowledge of factorization might be called upon, because it is still mathematics, and if we factorize the expression, then we may stand a chance of reducing it. So let us factorize that difference of 2 squares. In factorizing the difference of 2 squares, we are attempting to find what expression we square to get 9x squared. So what do we square to give 9x squared? We square actually 3x. Therefore 3x will be in the brackets there and there. And then we say, what do we square in order to get y squared? What do we square in arriving at y squared? The answer is y. So there we have y squared is the square of y. Y will occupy the second positions in each bracket. So we are saying, what do we square to give y squared? The answer is y. So y will occupy those positions. And in factorizing the difference of two squares, what is next? One pair of brackets will contain a positive sign and the other will contain a negative sign. And as a matter of fact, it does not matter which one, as long as one is positive and the other is negative. The expression in the denominator may be factorized by using the most basic principle of factorization, namely, take out the highest common factor and divide each term by the highest common factor. Normally, we do not include the intermediate steps in factorization. That is why we do not have them on the script. We only include them when explaining the process. The highest common factor of this expression is 3. We will also divide each term by 3. And we are factorizing the denominator, the original denominator, and we are taking a common factor of 3. And we are dividing each term by that common factor of 3. And we will see 3 into 9, giving 3. And in the second term, the 3's will cancel. So we have 3 into 9x is 3x, and the 3's will cancel there. So we have the common factor of 3 and the large factor, well, quote unquote large factor, is 3x plus y. Rewrite the expression with the numerator and the denominator in factorized form. And I hope that we will remember from the previous slide, 9x squared minus y squared is a difference of two squares. Then, for that difference of two squares, what do we do? As a matter of fact, we have factorized them already, both numerator and the denominator. So we will write the factors. So the entire expression is written in the factorized form with the numerator factorized and the denominator factorized. And do we see any common factor? Yes, 3x plus y is a common factor. We will reduce by a common factor of 3x plus y. So we have 3x minus y over 3, and that is the simplified form. Do not let the nature of this problem deceive you. We are still adding and subtracting fractions. Apply the same principles that we have used in the other tutorials. We need to consider that the numerators are not single numbers, but are comprised of algebraic polynomials, as a matter of fact, binomials. Each of them contains two terms. So being polynomial with two terms, that's a binomial. The usage of brackets will no doubt become very important in adding those fractions. Two very important things to keep in your mind are: 1. When expanding the brackets, the term that precedes the brackets should be distributed to all of the terms that are inside of the brackets. Remember that one. And 2. Be explicit with the use of the brackets and consider diligently the signs and their combinations. So we still have to be on top of our games, not because we are dealing with fractions now. That means we need to taper off on the importance of the things that we have done before. No, we need to maintain that level of seriousness with every single aspect of the solution. No doubt we are including another component, which is the fact that we are handling fractions. But we have other things to do that we have done before, like the combination of like terms and also the expansion of brackets. So let us go and perform our duty, keeping in mind all of what we need to do, and we will not treat any with any less level of seriousness than the other. So we will add fractions with exclusive denominators just like we have done before. Adding those, we will multiply the denominators, and that will be the denominator of the new fraction. And what do? The same. Multiply those two. But because we have that single 3 to be multiplied by these two terms, what do you know that we need to do? We need to include those two terms in brackets. And what about that? We need to also include those in brackets. And I think that we are saying that the sign that we have there that pertains to the entire second fraction should be included at that appropriate place also. The sign is pertaining to the entire fraction and should be the sign of the number that multiplies the brackets. So we are saying that this sign pertains to the entire fraction, and therefore if we need to use the 5 to multiply the entire expression that we have in this bracket, then we need to include the sign here also. And we will do the same as before. 3 times 2x, 6x, and we need to do that also. Then we do that. Do not forget that it's a negative 5 that we are multiplying, so negative 5x. And we do not write down the 2 here, but we take the negative 5, multiply that 2, we get negative 10. Then what do? Combine like terms. 6x minus 5x is equal to x. And what else do we know? Positive 9 minus 10. The signs are different. Subtract the smaller from the larger, and the answer will take the same sign as the larger. The larger one is 10, and it is negative. The answer will be negative, and we take the smaller one from that. But we just do not jump and subtract smaller from larger. When do we do that? We do that when the signs are different. And of course, the signs are different on this occasion. A negative 1. No reinvention of the wheel here. All of the processes that are not discussed in detail were explained and over-explained in previous tutorials. And we will add again fractions that we call fractions with exclusive denominators. And we will do the same as we have done before. The new denominator will be the product of the denominators, and we multiply those two. And do not forget that we are multiplying by those two terms in the numerator, and those two terms need to be placed in brackets. And no doubt 3 2s 6, but do not forget the sign that we have right here. Then what do? expand brackets as usual. 3m to be multiplied by m, that will give us 3m squared. And what about that? We multiply m by 2, we get 2m, and we have what? A negative 6 right there. And finally, there are no like terms. We therefore do not combine any of the terms. When adding or subtracting algebraic terms, we can only combine like terms. When combining like terms, we add the coefficients and the indices are not affected. I have the space here, so I am just taking the opportunity to remind us, although we are not actually doing it, that when we add like terms, the indices are not affected, only the coefficients are combined. And what do we know about that one? Maybe one that you like very much. The same, because we are adding fractions that have denominators that do not have a common factor. We multiply the denominators, and that will be the denominator of the answer. Then we have what? 3p times q, no doubt 3pq, and what? 2 times p is 2p. And the way that we breezed through this problem, one might just be wondering, where is the level of difficulty? However, I have seen students add fractions by simply adding the denominators and adding the numerators. Others, I do not know how they arrive at their answers. Let us say that they are thrown off by the fact that the fractions are algebraic in nature. Irrespective of the nature of the fractions, we may find their sum or difference by applying the same principles. So if we are adding algebraic fractions, or we are adding just numeric fractions, then the principles that we apply in adding them will no doubt be the same, because it is addition of fractions nonetheless. Here we have somewhat of a different situation from what we are accustomed to in these tutorials. We have more than 2 fractions. Also, the denominators are not exclusive. Now that we have 3 fractions, what do? We cannot, when we are adding 3 fractions, take the simplified approach that we have taken on the other occasions. That simplified approach is applicable when we have only 2 fractions. So we cannot do that. And as a matter of fact, we have y here and y here, demonstrating that the denominators are not exclusive. It is not difficult to add or subtract them. We will go straight to our instruction that we were given in primary school. Find the smallest number or minimum expression that all of the denominators can divide into without leaving a remainder. And that will be the LCM of the denominators, and that will be the common denominator. In this case, the LCM of the denominators is 2y. It is divisible by 2 and it is divisible by y. We remember how to progress after finding the LCM of the denominators, but we will take a closer and more detailed look at it on the next slide. So we know exactly what to do from primary school, but we will not just do it on the next slide. We will, as a matter of fact, take a very close look at it and work out the details. So I'm demonstrating that this is what we are actually doing when we add fractions in the manner that we will see in a minute. When we have those fractions to be added, we take a common denominator. Then we say what? Y into 2y is 2. 2 5s 10. We say y into 2y, 2. 2 7s 14. Then we say 2 into 2y, and that is y, and so on. But let us take a look at what really happens. Each fraction is multiplied by the LCM of the denominator, and the result will be placed in the numerator of the answer. So that is what we do. We take the 5y, we take the 5 over y, and we multiply that by 2y, and the y's will cancel. 10 divided by 1 is 10. Then we take the other fraction and we multiply by the common denominator, and what happens? That's gone. 14, and we take that one, and the 2's are gone, and we have y right there. No problem whatsoever. And I am sure that the problem will not appear when we complete the simplification of this expression by adding the integers or the like terms. The integers are the only like terms and are combined. Y is unique and returns as it is. There we have it. We are choosing to write that negative 4 at the end, and the unique term, which is a positive term, at the beginning, because mathematicians do not like to begin an expression with a negative term, especially when it is not completely necessary. Add fractions with exclusive denominators again, and no doubt we multiply those denominators and we multiply those, and we do that again, and what do we have? What do we say? 4 returns as it is, and 3 times a is 3a. Now we have a positive 3 to be multiplied by a negative 2. And what do we imagine? The result is a negative 6. So we have like terms and they are combined by adding their coefficients, and the unique term is included without alteration. So we are taking the like terms, these two, and we are adding them by adding their coefficients. 4 plus 3 is 7. So we have 7a and minus 6. And that is all there is.